looks good to me. Damn it, that's annoying. Should have been paying more attention, but I was so relieved when I was done with that finally. All right. So unfortunately, this next one, I starred because I honestly have no idea. So we may just, I'm going to look at it for a few more minutes. Like what I do is I basically just read through the problems the night before, and just try to see if I can, subconsciously think about it. But I don't know if it really helps. But I do know that I put a star next to this problem, which means I really had no idea how to do this. Anyway, it's a very short description, so at least we have that going for us. But let's not forget to do certain things. Let's chapter 3, problem 3. Q via stack. .clj. Okay. So we aren't going to need this. We're probably going to need the same 4 operations we always have. We're not going to need this special popper. And which I did think this was very nice how we're basically able to use, this guy in this popper, right? I guess, anyway, I thought that was cool. Obviously we're not going to be testing pop_at because it's not in this function. But what is this function? Okay, so this function is Q via stacks, and it's basically implement a myQ class, which implement a myQ class which implements a queue using 2 stacks. So it's very simple. Implement a queue using 2 stacks. I can see doing it with 3 stacks, but with 2 stacks, I'm honestly confused because you can pop off 1 stack and you can put it onto the other stack, but then all you can do is pop off the other stack. I'm sorry, stack 1 and stack 2, right? You can pop off stack 1 and put the result on stack 2, or you can pop off stack 2 and put the result on stack 1, but it doesn't affect the order, right? Or I guess the only thing, when you pop onto 1 stack, when you move from 1 stack to another stack, right, all you're doing is reversing the order, right? But that's a terrible, terrible... I guess maybe it's not. Maybe if you know that you're going to be doing like 1,000 queues in a row, and then 1,000 pops in a row, and then 1,000 pushes in a row, and then 1,000 pops in a row, then maybe it doesn't matter that 1 in 1,000 times you have to fully reverse the entire stack, But if you're truly limited to just having 2 stacks and a queue, and you were to interlace them, right? Your stacks and your queues have, well, I guess if you were truly to interlace them, you'd never have more than 1 item on your stack, and so that effectively makes it constant in cost. But no, let's say you were to queue 1,000,000 items onto your stack, and then for the next 1,000,000 calls, you were to interlace pushing and popping 1 item off the stack over and over again, right? Every time you do that push and that pop operation, we literally have to reverse the stack, right? Because we need to know the bottom and the top over and over again. And that's insanely expensive, right? And so that's my thinking. And I'm wondering, is there some clever thing I'm missing about using 2 stacks for a queue? I guess you could maybe... What about... So stack 1 is acting as a stack, and stack 2 is acting as a reverse stack. And a reverse stack is effectively in the correct order for... A fully reverse stacked is in the correct order for... a queue pop operation. I'm going to call it pop, even though I think they call it... What do they call it? So queue has peak, it has remove, and it has add. Yeah, so queues have add, remove, peak, and is empty. Wait, does a peak on a queue return the first item in the queue or the? If first is equal to null, okay. Return first data. What's the purpose of having a peak that returns the beginning of a queue? I don't care about the beginning of a queue. I care about the end of a queue because that's what I'm taking off of, right? No, I'm putting onto the end of the queue. I get it. Okay. So peak returns first data. Remove. Okay, yeah, okay, I get it. Yeah, I just had it kind of backwards in my head. Add. Let's just make sure that add adds onto the end. Okay, if last is not equal to no, I'm just reading code here. Last dot next. Okay, yeah, last adds on to the end. Okay, that makes sense. All right. So, okay. So, queues via stacks. Yeah, I mean, other than just paying a linear cost, I can't see any. I mean, it's clearly a pretty abysmal data structure. But if we truly are going to implement it with two stacks, I can't see how you do anything but pay a linear cost to it. Um, am I missing something? So that was a big like moment for me. Stack number 3.2, which I incorrectly labeled. Um, Realizing I could put the value in the. I could put the value. I could put the min in the actual stack at that moment. Is there something clever like putting additional data in the nodes that lets us not have this problem? All right. So obvious solution is to just reverse the stacks with the second stack. That's the obvious solution. My queue class, which using two stacks. Um. Yeah. Using two stacks. uh, what can you do with two stacks? Um. Golly, nothing super obvious other than just reversing the existing stack with the other stack. I'm trying to think, can I write anything into the nodes such that I could, like, okay, here's an idea. Here's an idea. What if we tried to keep the two stacks balanced, right? So it's not really about stacks. It's just because no, we need the fully reverse stack, right? We can't just balance them. We need. What if we? I was trying to think, yeah. All right, let me just think. Let's think about this. Okay, the 0th case, you have an empty stack. You have stack A and stack B both have no items in them. The first case, you have one stack. Stack A, you'd put V. I'm just going to say you're putting 1 through 5 onto the stack, right? You put 1 onto the first stack. You could also put 1 onto the second stack, right? Those are like, and then if you wanted to drop it, you just drop it from both stacks, right? Um, what about putting 2 onto the then I push 2 onto the stack, right? Now that I'm pushing 2, I can push 2 on top of the first stack, but I kind of need to pop everything off the second stack because the first thing that comes off should be 1, not 2. Sure, I mean that's just getting linearly more expensive. There's nothing clever about that. I can pay the linear cost at many different points. I could pay it at pop. I could pay it at remove. Or at least I can pay it at pop. I can pay it at push. I I can pay it at many different places, but somewhere a linear cost has to be paid. It feels like. Well, I'm tempted to just look at the hint right now, but I'm just gonna do it the way I can think to do it, which is not very clever. So I'm gonna keep 2 stacks. One is the I'm not gonna call one the stack and one the queue, but one is the ascending stack and one is the descending stack, you know. And let's see what we got for is empty. It's empty if it's equal to this. That is what defines it as empty. Okay. It's... We should actually call that stack empty. I don't like is. So stack empty. Fine, we'll do is. Stack is empty. Okay. If the stack is equal to the 0 stack. The second one is the stack... can we peek the stack? Well, we should be able to peek any... Actually, I don't even know whether this is necessary. Like, if I'm just going to pay the cost whenever you pop off the queue, maybe instead of doing this, I should just say... I feel like I'm going to write such a complicated solution, and it's going to work, but then I'm going to look at the hint and realize there's an incredibly simple way to do this, and I'm going to feel like I wasted my time. But let's just stick with it, you know? So, I mean, I can either do it like this, or I could also say that it's, you know, this data structure is defined as a direction, right? Which could be ascending or descending, right? And is also a stack, right? Which, but I think I'm going to stick with this for now. It's not. Maybe I shouldn't call it ascending and descending. Maybe I should just call it. That's not really. Well, I guess we called it a queue stack, so maybe it's okay to call one a queue and one a stack. All right. But only one of them will actually be... I can really only use one of them at a time, honestly. But I'm going to stick with it. This is like the simplest solution I can think of, given that I am fully accepting the fact that this is a terrible data structure. Queue stack. All right, so we got stack is empty. It's empty when it's equal to the queue stack initial. We got the peak on the stack. What does that mean? Well, one of these two is going to be how about we make it so that one of these two is actually nil at all times? That actually makes some of this a little bit easier. Okay, and actually, then we can also say that the stack I'm going to just call it QS from here on. With the QS, right, if we take... Ugh, I don't like this. I don't want to run through all the conditionals on it. I don't want to... I mean, literally, we're going to have to do double code for every single one of these. Like, what does pop need? Pop needs all the stack, all the data, all the items to be in the queue form. Since we're kind of giving these weird names, I'm just going to say, all right, is empty, my peak, my pop, my push, and Q stack. Okay. So I don't really care which one is actually in play right now, because only one of them should be non-nil. But I do care that one of them is in play. And I'm going to say is QS right? Is one of these empty? And because I'm using nil, it'll pass by the nils and take the stack. For instance, the stack, or if the queue happens to be once full, just take the queue, and that'll return that value. So that's my is empty. My peak. Yeah, peak is defined. I mean, I don't really think there's a peak is defined in terms of the item you would pop if you popped it. Yeah, so it should always be the case that we've put things into queue, or sorry, into. Wait, are we? The queue should pop off the item that you would have peaked. Actually, it should remove the item that you would have peaked. Right, so that's the first item. Okay, that's fine. Okay, I'd like to state, just for the record, that if we were actually to ask me to do a queue, I would definitely use a map, right? That's just far simpler. You can use a map, you can just have an infinitely incrementing series of integers, right? So you need to keep track of 3 integers other than the map itself. You need to keep track of, actually just 2, I think. The current max and the current min integer, and then an actual reference to the map itself. With that, you can implement a queue, right, in an immutable language. But if we are going to try to do this queue with 2 vectors, which is not a good idea, you know, or at least I don't see it. Okay, all right, we'll move it. I just want to state that that is how I would actually do this, not with this double stack thing, which is just I'm not. I'm almost. Oh man, I'm so tempted to look at the hint just because I feel like I'm probably just missing something super like, oh, that'll make it so easy. But like my solution that I'm suggesting isn't even a good solution. The best I'm doing is at least making it such that if you are to do successive, you know what? Screw this. I'm not going to even optimize for that. I'm just doing a stack, and I'm just doing a stack, and for the rare Q, I'm going to, right, I mean, instead of doing my pop, effectively I'm doing my remove, because it's a magic Q, right? And, or it's a doubly, it's a Q with 2 stacks. So, yeah, how do you ask if the stack is empty? Well, you ask if the stack is empty, right? On the Q stack. How do you peek at the stack? Well, you peek at the stack, you know? Let's just, I mean, if you're going to write a bad solution anyway, you might as well just write a simple to read bad solution. How do you ask if you can, well, that's the complicated one, or that's one of the 2 I guess that's the only 2 really, so. Okay, so we've done half of it already. Yeah. Now the question is, okay, if I want to push onto the stack, that's trivial, you know? I just literally conj onto the stack, or we're calling it, what are we calling here, QS? Really, it is just a stack. I'm gonna start calling it VS. I don't like this. Yeah, conj onto V onto VS, right? If you're gonna push, yeah, let's call this VS. Ooh, yeah. I did not P, but yeah. Peak. VS. If we're okay, all right. And finally, so everybody's really easy except my remove, which we're going to do in a monstrously inefficient way by basically taking the VS, we're going to reverse it. We're going to vectorize it again. We're going to pop it. And then we're going to reverse it again. Does that make sense? Almost, except that actually my peak in this case, I think, is just the first of VS, not the peak of VS. All right, because let me think about it. On the stack, or in my stack, in this magical stack we're using, we're basically, yeah, the first item on the vector is actually the oldest item. So that would be the one that you would want to remove if you were to remove it. So if we reverse this, now the oldest item is now at the front of the vector. And then we just convert it into a vector. And then we pop the item off the front. Which is the oldest item. We reverse again and convert that back into a vector. You tell me, I don't know. And you might say, are you using 2 vectors? Well, are you using 2 stacks? Well, effectively I am, right? I'm converting one vector, I'm converting my existent vector stack into another vector stack, right? That's my second vector. And then I'm converting that back into another vector. You know, so I'm only using, at any point in time, 2 vectors, right? Immutable data structures, it's different, blah, blah, blah. But I guess, yeah, technically this does use 3n space, right? Because I kind of need to keep, well, no, actually I'm not even sure that's true. Who cares? Yeah. I feel like this is, well, I'm missing something very obvious about solving this. So anyway, test the peak functionality for this. Everything should work identically, basically. Except that rather than having a pop, it'll be a remove. And I guess, I think it's a pretty simple data structure. It's just a map, literally, you know. Wait, why is that doing that? There we go. Oops. All right. And I misnamed this one, didn't I? At least I detected it ahead of time. Holy crap, I did it again. All right. God, I hope I didn't just screw stuff up, but queue via stack. I don't know what that does, but okay. Let's see what we got now. All right, and sure. I mean, it's a yeah. Let's see if that actually works. Or just stack of plates. Well, that's obviously 124. Queue stack. Yeah, okay. My pop, my peak. Well, I should have used local replacements. And we don't have a pop. Okay. Where's my pop? Two places. It's my remove now. And where's my pop? Okay. Test the peak functionality for blank. Test the peak functionality for blank. Okay. So what do we try to do? Well, oh yeah, I guess it is reverse now, right? All right, let's actually try using it in succession, you know? So, um, if I my push onto 1, 2, I should get if I push 3 onto 1, 2, I should get 1, 3, right? Yeah, okay. How about if I my remove off of 1, 2, 3, I should get 1, 2, right? No, actually, I'm wrong. I should get 2, 3. Okay. Alright, I think that makes enough sense. Alright, so let's see what the hell I did wrong there, because that's just... Alright, 98. Hint number 98. Alright. The major difference between a queue and a stack is in the order of elements. A queue removes the oldest item, and a stack removes the newest item. How could you remove the oldest item from a stack if you only had access to the newest item? I could pop the entire stack. Okay, so what was the next clue? The next clue is number 114. Alright. We can remove the oldest item from a stack by repeatedly removing the newest item, inserting those into a temporary stack, until we get down to one element. Then, after we've retrieved the newest item, pulling all the elements back. The issue with this is that doing several pops in a row will require O(n) work each time. Can we optimize for scenarios where we might do several pops in a row? Yes, we can. I do not want to do that. That's just, like, we started on that path, but I thought this code is so bad that I can't possibly think this is the right solution. Looks like it is the right solution, but I don't care, you know. The optimization is to basically leave it in whatever order you last did it in, and don't switch back and forth, or don't always basically just do this one time. Instead, leave it, you know. If you needed it to be in the queue form, right? Leave it in the queue form. If you need it to be in the stack form, leave it in the stack form. That way you can do them successively. Not dealing with it, you know. Too much. So I got bigger problems. All right. Whoops. CK. All right. That actually surprises me. I thought they were going to come at you with something like, oh, there's some clever thing you can do, and now yeah, the fact that it was exactly as we saw it, it's a bit surprising actually. But okay, anyway. Q via stack.